Welcome to this video on adding and subtracting polynomials. Let's begin. Before we learn to add and subtract polynomials, let's do a brief review of why parentheses are so important. So in these examples, we are going to be using order of operations, which is, please excuse my dear Aunt Sally. So remember, that tells us that anything in parentheses has to be evaluated first. So here we have 5 plus 8, which is 13, and we have 7 plus 2, which is 9. Then we would have 13 plus 9, which of course is 22. Let's say, however, that I did this without the parentheses. So in other words, it's just 5 plus 8 plus 7 plus 2. So if I did it in a different order, I would have 5 plus 8, which is 13. 13 plus 7 is 20. And then 20 plus 2 is 22. So how come in both of these examples I got the same result even though I did things in a different order? Well, the answer is that everything is connected through addition. Therefore, the parentheses aren't really doing anything because you may recall addition is both commutative and associative, which means that I can move my numbers around and I can change the order of operations and I'm still going to get the same exact answer. However, let's look at the second example, and hopefully you notice this one small but very important difference, which is that the 5 plus 8 and the 7 plus 2 are now joined not by addition but by subtraction. Okay? So again, I'm going to do 5 plus 8 first, which is 13, because that's what order of operation tells me to do. Then I'm going to do 7 plus 2, which is 9. Then we have 13 minus 9. 13 minus 9 is what? Is 4. Okay? So what if over here I try to do this in a different order? In other words, what if I try to do it without the parentheses? Okay, is this the same? That's my question. Okay, so 5 plus 8 is 13. 13 minus 7 is 6. 6 plus 2 is 8. Okay, so we can see that these are definitely not the same. So why this kind of shows you and demonstrates why parentheses are so important. Because actually what we're really doing, right, is we're not really just subtracting 7, we're actually subtracting the 2. And what you're going to learn when we get into polynomials is you're going to learn that we can actually put a 1 here and we can distribute this negative sign. And if we did that, then we would have 13 minus 7, which is 6. And then if we have 6 minus 2, then we would get 4. And now, right, we have the same answer in both cases. But again, I can't drop the parentheses without distributing that negative sign. So that's just a brief introduction to why parentheses can be very important. So let's do some brief review. So first of all, what are like terms? Like terms are terms that have the same variable or variables raised to the same exponent or exponents. However, the coefficients of the like terms can be different. So let's see if we can figure out some examples. So what about 2x and 3x? Are those like terms? Absolutely, right? Because they have the same variable, which is x, and it's being raised to the same power, which is 1. What about 2x and 2x squared? Are those like terms? They are not like terms, right? Because they have different exponents, even though they have the same variable. What about 2 and x? Those are, again, not like terms. What about x cubed and 2x cubed? Are those like terms? They are, because even though they have different coefficients, they have a coefficient of 1 and 2, they have the same variable x raised to the same exponent 3. So that's a brief review of like terms. So the other thing I want to cover before we start doing some examples is what happens when we add two terms. For example, what if I have 4x squared plus 3x squared? So a lot of times, students are very tempted to tell me that this is going to be 4 plus 3, which is 7, and then they want to add the exponents, and they want to tell me that this is 7x to the 4th. Okay? So, remember, if you can't solve a problem, right, solve a simpler problem. So think about it. This is really simple and dumb, but it works, right? Think about it and just say we're counting bananas, right? If you have 4 bananas and I have 3 bananas and we put our fruit together, right? Together we have 7 bananas. So treat x squareds exactly like bananas. If you have 4x squareds and I have 3x squareds, together we have 7 what? X squareds, right? There is not an x to the fourth in sight. When we're adding and subtracting, we're literally just counting things. And the things that we're counting do not ever change. If I said that 4x squared plus 3x squared is equal to 7x to the fourth, that's exactly like saying if you have 4 bananas and I have 3 bananas, together we have 7 coconuts. Okay, that's insane. That's crazy. You can't do that, right? When we add bananas together, they don't magically turn into some other fruit, right? You just have more of what we have, okay? So again, be careful, okay? Resist that temptation to combine the exponents. What operation causes us to combine the exponents? Well, it's not addition, but it's multiplication. Remember that? It's only when we multiply terms like this, right? And then we rearrange our furniture, okay? And then we'd have 4 times 3 is 12, right? And then this is where we can apply the product rule because we are multiplying these two things, and that would give us 12x to the fourth. Okay, and that's where my fruit analogy breaks down because I don't know how to multiply bananas times themselves and get a meaningful result. That makes no sense to me, okay? So, again, when we are adding, okay, we're literally just counting things. And the things that we're counting do not change just because we counted them. So, 4x squared plus 3x squared is equal to 7x squared, okay? Do not change the exponents. Resist that temptation. All right. So let's look at our first example. So we have 4x cubed minus 2x plus 8 plus 3x cubed minus 9x squared minus 11. So because of this addition sign, right? Remember, addition is commutative, right? Meaning the order doesn't matter, okay? And so what we can do is we can drop our parentheses, okay? So this is going to be 3x cubed minus 9x squared minus 11. So then, the next thing I want to do is I want to combine like terms. If you want to, what you can do is you can rewrite this problem so that your like terms are adjacent. So that's what I'm going to do. Oops, that's not a square, that's a cubed. Sorry, that was a typo or a right-o. Okay, so I'm going to write 4x cubed plus 3x cubed. So again, count with me, right? If I have 4x cubes and you have 3x cubes, together we have what? We have 7x cubes, right? The thing that we're counting doesn't change just because we counted it. Okay, then we're going to go into descending order of exponents. So then we have a 9x squared, a minus 9x squared. I don't see any like terms to group with him, so he's just going to be all by himself. Okay, then we have a minus 2x. Again, bring him down, he's all alone. And then we have a plus 8 and a minus 11. So, oopsies. Plus 8 minus 11, and that's going to give us a negative 3. So that's it. We're all done. And notice, right, these terms, none of them are like terms. So I cannot combine 7x cubed with 9x squared or 2x or any of those other terms. So my final answer is 7x cubed minus 9x squared minus 2x minus 3. That's the final answer. So in example 2, just want you to pause for a second and see if you see an important difference between these two. So the important difference is that this is now a subtraction. So remember when we said when we have a subtraction, right, we cannot just drop our parentheses because those parentheses are actually serving a purpose. So before I can get rid of my parentheses and combine like terms, what I have to do is I have to remind myself, hey, there is a negative 1 out here. So what it's going to do, right, that negative sign is going to toggle or flip all of the signs of all of the terms inside of that. So the first set of parentheses, none of those terms are going to change. So we have 5x squared minus 2x plus 7. Nothing is changing there, okay? Then we have minus 3x squared minus 6x, and then we have a plus 4 because minus a negative is the same as plus a positive, okay? So I want to show you a cute little trick. If you happen to have two polynomials that have all of the same variables like this, what you could do, and you certainly don't have to do this, but I think it's kind of convenient, is what you can do is you can write these terms below instead of right and left of each other, and then you can combine them that way. So I have a 5x squared minus 3x squared is 2x squared. Again, remember, if you have 5 apples, you eat 3 of them, you have 2 apples left. The thing that you're counting doesn't change. Okay, then we have negative 2x minus 6x. Negative 2 minus 6 is negative 8. And then we have 7 plus 4 is equal to 11. So this is a perfectly acceptable way to organize your information. My only caution is that just make sure, right, that you have like terms above and below each other. So for example, if we try to use this method, right, in our previous example, it would be a little bit tricky because we have a 4x cubed and a 3x cubed. But look, notice we don't have any x squareds. Okay? So we would have a 0x squared here, minus 9x squared here. Then we don't have a then we don't have an x here. So it would look something like this. Okay? So again, you have to have 2 placeholders because one of your polynomials has an x squared term and the other one doesn't. One of your polynomials has an x term, the other one doesn't. Okay? So again, you can still use this technique, but be careful that you don't accidentally combine, for example, the negative 9x squared and the negative 2x, because those are not like terms. Okay? So again, this will work some of the time. It will work all the time as long as you use those placeholders. Okay? And if you're worried or concerned that this method isn't going to work for you, then you can just go back to the other method that I showed you, where you have 5x squared minus 3x squared, right? That's 2x squared, and then you have minus 2x minus 6x, that's going to give you minus 8x, and then plus 7 plus 4 is plus 11. Okay? All right, let's look at the next example. So now we have not 1, not 2, but 3 polynomials. Okay? So we want to be able to drop out parentheses. However, the one, we do have a negative sign here. Right? So we have to simplify this a little bit first by changing all of those signs there. Okay, so this is going to become a negative 1x squared plus 9x minus 8. Okay, so let's see if we can use that shortcut method. So we have 2x squared minus 4x plus 3. And then I have a 5x squared minus 6x plus 1. And then I have a negative 1x squared plus 9x minus 8. Okay? So this is going to be 7. 2 plus 5 is 7. 7 minus 1 is 6. Okay? Then we have negative 4 plus negative 6. That's going to be a negative 10. Negative 10 plus 9 is negative 1. Then I have 3 plus 1 is 4. 4 minus 8 is negative 4. Okay? And I can write that more simply by just writing a minus x instead of a minus 1x.